In the previous video segments, we created a simulation model for our coin flipping game, and we generated 10 iterations within one simulation. And here are the statistics for this one simulation consisting of 10 iterations. And we found out, right, minimum, maximum value, average or mean payoff. And we also found out the confidence interval for the mean payoff. And so we found out the simulation is inconclusive. Before we increase the number of iterations and generate another simulation run, I want to step back a little bit and ask, why am I looking at the mean payoff? Is the mean payoff the right parameter to answer the question, is this a winning or losing game? And what I want you to see is that this kind of game is something that we probably will play repeatedly. If you have a casino that offers this game, then you would probably play it many times, and sometimes you win, sometimes you lose. But the question is, will you win on average? Because if you win on average, the mean payoff is actually positive, that means after a large number of games, you will have more money than you started with on average, right? So on average, you should win the mean payoff. If you play this game 1,000 times, and this is truly the mean payoff, after 1,000 games, you should have around 1,000 times 20 cents, $200. So this is the right answer. It is something, it's a repeated game. And for a repeated game, a mean or expected value of the payoff is something that we would be interested in. So as we said, the confidence interval is too wide. It includes negative values, right? The range covers both negative and positive values from minus 2.74 to plus 313. So we're going to increase the number of iterations and run the simulation again. And I'm going to increase it to just 1,000, the default value. And then I'm going to click simulate again. Let me go to the mean payoff and then simulate. And again, now the simulation will run, but notice it will take a little bit longer. Now it's finished. We see the distribution, and the distribution has become more interesting. What I want you to see is that plus $5 here, it's actually happening quite frequently, and plus 3 and plus 1, and then minus 1, minus 3, minus 5. And there are actually much higher negative values, right? And we can close this and we can actually look at the values that we see here. So notice minimum payoff is now negative $51. So there must have been at least one game, one iteration within those 1,000 where the winning, the payoff was negative 51. So we had a total of 59 coin flips in this one iteration. And maximum is still 5 because actually this is the maximum you can hope for. And notice what happens to the mean. The mean is now negative 81 cents. So on average, this says we're losing 81 cents. But what is more interesting is the confidence interval. And I want you to see that this confidence interval stretches now from minus 1.35 to minus 0.26. So both upper and lower limit, or lower and upper limit of this confidence interval are on the negative side of the right of the value line, right? So they are both below zero, and therefore we're 99% confident that this is a losing game. On average, we will be losing, right? And I want you to see, first of all, these values are much closer to each other, right? There is just about 1.1 difference between them. They are much closer. Why is that the case? Because I have a much larger sample, and if you actually check the formulas that calculate upper and lower confidence interval limits for the mean, the number of iterations when you increase, or the size of the sample when it increases, the confidence interval size decreases inversely, not proportionately, but it decreases at some right range. So by this simulation now, simulating 1,000 iterations, you see that we can now confidently answer that this is actually a losing game, and we shouldn't play it if we're interested in winning. We can still play it if we just want to play for fun, but we should expect to lose money on it on average from this simulation, 0.81 cents, right? 81 cents per game, or actually the mean is somewhere in this range. So we actually don't know if it's 81 cents or somewhere right from between 26 cents of loss to $1.35 of loss.